Hi everyone, my name is Rebecca. I'm a fish biologist and ichthyologist and also a PhD student. I specialise and study the evolution of lower card catfishes, which are also known as plecos, whiptail catfishes, cichlids, ottos, etc. within the aquarium hobby. But let's talk about a big topic within aquariums, and that is actually about nitrates. And this is more think about the environment within an aquarium. Most of the time when we think about water quality, we're thinking about a few things, usually like ammonia, nitrites, and then nitrates. They can be confused because ammonia is NH3, NH4, nitrites is NO2 and nitrates is NO3. So they kind of look similar, and nitrates and nitrites, but they're kind of a little bit different. Nitrites are definitely particularly toxic and they can kill particularly quickly, they can rise particularly quickly, and they can disappear particularly quickly because we have the bacteria and aerobic bacteria in our filters particularly that will process it, not so much on anywhere that doesn't get as much flow. So that's kind of sorting out nitrites anyway. Ammonia, same sort of thing, it's particularly toxic, gets processed quickly in a cycled aquarium. But today, me talk about nitrates. This is not a topic really, I think, for beginners without nuance, or it takes understanding scientific literature, the limitations of science, and actually understanding science in general and just scientific practices, because a lot of us are relying on that for what we think about nitrates in a way, because it is a little bit of a complicated topic. So online you'll see that nitrates aren't that toxic or aren't toxic. Firstly, they are toxic, and that is pretty much confirmed across the scientific literature. But like most things, there is something called like an LD value, so that's kind of the value before you get about 50% of the population will suddenly die, I think it is. But that value isn't entirely useful for us. Nitrates are toxic. We've got plenty of studies to show that. So I think the argument about nitrates is really at what level are they toxic? And when we're asking this sort of question, it isn't exactly that simple, because with fishes we're not dealing with just one species, we're dealing with many species that can be hundreds of millions of years apart, and they come from different ecosystems, they have different physiologies, and there's a clear difference between wild and captive, and this will depend on what individuals they are. So there's so many variable factors when it comes to the actual toxicity of nitrates. So we know it's toxic, and it's just what level, for what toxicity and what effects. So an important term sort of to clear up here is acute, which is a sort of very short-term effects, short-term toxicity, versus chronic, which is long-term, and kind of where the fish is exposed to nitrates over a long term rather than over a short term. Because if you're thinking about it, those nitrates, if you're doing a short exposure at higher exposure, I guess would be the better way of saying it, then it's going to have different effects, or it's not going to show certain signs opposed to long-term exposure. And then we think about how long, and this is where the science really gets into it, because a lot of studies, they might be doing a few days, they'll have to do repeats most likely. So even a 3-day trial will take a lot of time. So a lot of these studies will do 3-5 days, and then you might also have ones which are a month. And then you have to ask yourself, are these valid as fish keepers, or what is the extent of their use for a fish keeper? Because we're not just keeping our fishes exposed in these parameters for a month, they're likely going to be in that for years and decades maybe. So whatever small effects you might see over those weeks, days, months, whatever, they might actually have larger effects over time. So this is kind of where the study design is important, and I haven't even got into why nitrates are toxic. There's other things, like most studies focus on aquaculture because recirculating aquaculture systems are really popular, and these are just where the water constantly turns over and it's got some kind of filtration. This is a short-term housing because these fishes are used for food, and they also want efficiency, so low costs for as much for as short of time as possible for a large fish as possible. So it doesn't really matter about the condition of the fish, and it has been noted that farm fishes often have a very low condition. There's kind of a load of different factors to that. So we have that kind of thing, and it focuses on very few species for a short amount of time. Few species, particularly like tilapia. There's a lot of studies on marine fishes, and we know that for marines they have a lower sort of the toxicity of nitrates, or the effect is lower at high exposures than for freshwater. And freshwater ecosystems are really low in nitrates, so a natural freshwater ecosystem will have around of 0 to 3 ppm in nitrates, and most of our fishes come from waters that are so low in conductivity and TDS that you'll know it's going to be really low, undetectable almost, in nitrates. And that's why there's, in a way, plants really struggle in these habitats because there's not as much nutrients, and they're kind of having to work on in other ways. Back to sort of species, it is certain taxa that are being studied, and it's understandable why. These taxa are not entirely related because it's stuff like goldfish, which some of us keep, but tilapia very few keep, salmonids next to no one keeps as a pet, so it's kind of these sort of food fishes mostly focused on. The goldfish, I guess, are a good model. Sometimes you might find a study on something that we might use ornamentally, but is that one ornamental example an example for all? And is that example, so if they study neon tetra, for example, is that applicable to all South American fish or all tetra? It's very difficult to say. And the main thing here is it comes into animal welfare. The other big thing about when it comes to study design and understanding the toxicity of nitrates is that most studies actually don't test low levels. So a lot of people say this is the maximum level and then you want to limit it. Firstly, most studies look at around 50 to 100 to hundreds of ppm onwards. So how can you make a judgment of 0 compared to like 50? If your base level is 0 then 50, it's kind of a little bit difficult, especially when it's short term and we've got all those other factors before. So that kind of it's not really reliable in a way to give these sort of values of this is the minimum before your fishes are going to suffer, because we don't really know when most studies are using these large intervals in short periods of time on certain taxa. So the other thing about it when understanding toxicity or how toxic nitrates are is most studies are only looking at certain features, and most people focus on LD value, so what it takes to actually kill the fish in a short amount of time, and we know nitrates don't do that. But do we really want conditions? Do we really want conditions where the fishes are going to slowly die because we're focusing more on this very quick death value almost? So do we really want those conditions where the fishes die sort of very rapidly? Not really, and we definitely don't want it where we're kind of ignoring long-term issues. So we're looking more at maybe studies that are looking at the physiology, so this might be the immunology, the immune system, the liver, well that's particularly affected by nitrates, and also sort of the blood and growth, activity, reproduction, stuff like that. Reproduction is really important for a lot of people, and it's not just short-term reproduction, it's long-term reproduction, and some fishes will breed in very poor conditions. But most studies will only focus on certain aspects of a fish's physiology. So this is adding even more complexity to the system when it comes to understanding toxicity of nitrates for fish keepers and what we actually want. So if you're if you're focusing on this death value, it's not really that helpful for fish keepers in sort of a long-term habitat, because you can say I've had 50 ppm of nitrates that long, then it's not really that much use, other than if you want to avoid killing your fish sort of very quickly, because nitrites will do that and ammonia will do that. Nitrates take longer, they're chronic. So thinking about it, like, what is it studying? And therefore you kind of want to look at studies like look at the liver, looking at immunology, looking at growth, activity, and that makes it really difficult to actually make a proper judgment. Well, judgment of just one study, it means that we don't really have many resources that look at it in a sort of a bigger picture. So there's one thing that most people don't mention, is because we trust our test kits entirely. Like, most of us rely on our test kits. You can't taste nitrates, you can't really smell it. You can taste or smell, I guess, some things that derive from it, but that's no use for us fish keepers. The thing is that test kits, how reliable are they? And I have spotted nitrate test kits where brand new out of the packet, one is giving really high 80 ppm plus and the other's giving undetectable. So then this means that we're kind of judging in the dark. And the one thing that we can control is water changes and how much we can reduce nitrates by. What we can't control is our tap, and that can have nitrates in. So that is a massive flaw. But if your water change it, at least you know it's going down to that base level, hopefully pretty frequently, because you're water changing pretty frequently. And this is the importance of actually water changing and why these no water change things don't work. Because if you're testing, how reliable is it? Liquid test kits, just because of them being chemical, sometimes they do fail, and if a batch does fail, and these are from multiple batches I've tested, because if you're using them like across different tanks, having multiple test kits going at once, that's when you start to notice things. And it can be from multiple brands, but particularly certain brands, I find certain ones, their kits tests can be a little bit out. So always think about reliability, and if you're getting something out of one, like you've opened a new bottle and it's giving you something totally different, maybe it's worth thinking about it. And there are maybe more reliable nitrate tests, such as Hannah. They're particularly good, but they are also expensive. And any reagents, I don't think they're nitrate ones, you can calibrate, which is also an issue. Also, how do you naturally, like, if you're going to do it calibrating nitrates, there's probably some sort of reagents around anyway. But the ones that are more scientifically used tend to be more accurate. The only issue is it does depend on the study a little bit to why they're using the test kit and how much they're relying on it. So don't always rely on your test kit, I guess. Rely on how well you're looking after your fishes. If you're relying on your test kit for saying once it reaches 40 ppm I will water change, will it ever reach 40 ppm? How sensitive is it, and is it actually giving you true value? Nitrates, what do they actually do? And I'm not going to go too much in depth because it's a lot, it's one sort of toxic value that kind of has a lot of influences. It causes liver damage, it does affect the blood. And how does it affect the blood? Well, it could be converted to nitrites, I believe, in the stomach, or also maybe in the blood as well. So it is also giving nitrite poisoning, but it's not kind of as large. It has other sort of physiological effects as well, and I've put loads of papers below. And even if the papers say at this level in this short time span it didn't have an effect, think about chronic or long-term effects. And when we're thinking about sort of this, there's so many other toxic compounds that take a long time even at low values, and heavy metals have to be a big one. So lead poisoning, you can have small amounts of lead and it not really be an issue, but over time it becomes an issue. That's because it does bioaccumulate. Nitrates, I don't think we really know, and at the end of the day, that's why I'm saying we don't really know. So the summary of this video is more that nitrates are bad. Whether we know the extent of them, we don't. But isn't it better to actually be cautious about nitrates and like water change, regardless of what your test kit's saying? Because isn't it better to give better animal welfare than relying on the assumption that it's less toxic, because we don't really have as many studies on it. There's not really any studies at low level exposure. So how can we assume that all the sort of the studies at very high levels is where it actually is toxic? So at the end of the day, we should be thinking about nitrates from the idea that we're cautious about exposure to them. Kind of wording it is like, nitrates are toxic. We don't really know how they affect fishes at low levels for long periods of time as we keep them in aquariums. Like how we do keep them in aquariums. So we should be on the precaution that they are harmful at low levels, because we know that there's no benefit to nitrates for fishes, and we know that they are toxic. So we should keep nitrates low for the benefit of the fishes, on the precaution that they are toxic at low levels, even though there is a little bit of suggestion that they are in the scientific literature. So hopefully that helps. This video is a little bit more complex because this is something you have to apply knowledge to and actually research yourself and think a little bit more into. You can't just get away with it in a way. So, and you can't just rely on certain sources, because they probably haven't, even if you look into a few papers, you've got to understand the methodology of the paper and actually look into that methodology and think, how does it affect animal welfare? But it's kind of also, why should animals suffer? Because there is a slight potential that we can sort of be lazy on the and it not have an effect in a way. So, and there's plenty, it's not, we should be thinking about high animal welfare even on the chance that it takes us more time and it might not have that much of a benefit, but it likely does, because we know that this compound is toxic. You wouldn't do the same with lead or arsenic or mercury or radiation. So why would you do it with nitrates? We know all of those are pretty much toxic, but also thinking about just long-term exposure at low levels and what low levels. When we think about pollution of rivers, that it gets a little bit more toxic, complicated, because it also how it interacts with photosynthetic life like algae and plants, and therefore I think some of the high levels that people think are normal are very anthropogenic, so caused by people. So hopefully people like this video. Hopefully it's useful and gives food for thought to research further. Don't forget we have a Discord server if people are interested in discussing fish, biology, aquarium biology, anything that goes a little bit deeper into fish sort of, husbandry. If you like my videos, please comment, like and subscribe. Don't forget I also have a TikTok which I need to post more on because I haven't this week, but I'm in my final year of my PhD now, so I'm really focusing a lot on that, which also takes up a lot of time with coding and stuff like that, because I've done most of my data collection. But anyway, thank you for watching and goodbye.